we're going to solve this differential equation using series. So let's go ahead and do it. So solution. So we'll start by writing down y as an infinite series. In particular, we'll write it as a power series centered at 0. So that will be the sum from n to infinity of c sub n times x to the n. And now we'll just take derivatives. So y prime, that's the sum. And this time the series starts at 1. And we go to infinity, and we have c sub n times n x to the n minus 1. Now if you're not sure why it starts at 1, try to think of it this way. If you take the 0 and you put it here where the n is, you get c sub 0 x to the 0. This here is a sub 0. That's your first term. This is equal to 1 times c sub 0 because x to the 0 is 1. So it's just c sub 0. This here is a sub 0. So when you take the derivative of a constant, that's 0. So a sub 0 goes away. So the 0th term goes away. So it doesn't exist, so you start with the first term. Let's take the derivative again. So y double prime, and here we start at 2 because the first term goes away. And we have c sub n, n minus 1, x to the n minus 2. Notice I only differentiated the variable terms. The constant terms just hang out. All right, after you take derivatives, you just have to plug everything back in to your differential equation. So let's do that. So we end up with the infinite sum from 2 to infinity of c sub n, n minus 1, x to the n minus 2 minus the infinite sum starting at 1 to infinity, and then this stuff here. And this is equal to 0. Okay. The next step, or at least the way I do it, is I set this equal to k. I want all my exponents to be the same so I can combine everything. So we'll set k equal to n minus 2. That means n is equal to k plus 2. For this one, we'll set k equal to n minus 1. That means n is equal to k plus 1. You can do this step in your head, that's fine. I like to write it down. All right, now we can combine everything, or rather, rewrite everything. Hopefully we can combine everything. All right, so n is 2, so you get 2 minus 2, so k is 0. And we go to infinity, and we have c sub, well, n is k plus 2, so you get k plus 2. And again, n is k plus 2, so you get k plus 2. n minus 1, that's k plus 1. And then you get x to the k, which was the whole point, minus the sum. Here n is equal to 1, so k is 1 minus 1, which is 0. So k starts at 0. Oh, that's nice. So you get c sub k plus 1. K plus 1, that's the n is k plus 1, and then x to the k. So this is an easier problem because we got lucky and they both start at 0. That's not always the case. So yeah, nice, easy problem. Now we can combine everything. So we have the infinite sum as k runs from 0 to infinity. And I'll use a bracket here. So we have c sub k plus 2, k plus 2, k plus 1, minus c sub k plus 1, k plus 1. And all of this is being multiplied by x to the k, right? And you set this equal to 0. So this really worked out nice. It's a pretty easy first example. Okay, so we have a polynomial, right? We have a polynomial. And over here we also have a polynomial. This is the 0 polynomial. You can think of this as 0 plus 0x plus 0x squared plus dot 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 forever. So two polynomials are equal only when their coefficients are the same. So that allows us to set this equal to 0. So that means that, let me do it over here, c sub k plus 2 times k plus 2, k plus 1, minus c sub k plus 1, k plus 1, is equal to 0. And this is for k equals, well, k starts at 0, so for k equals 0, 1, 2, 3, etc. It's important to write this down or at least be aware of it, especially in the harder problems. All right, so now what I like to do is solve for the one with the largest subscript. So we'll solve for this guy right here. So c sub k plus 2, I'll just do it in one move. So we'll add this term to the right-hand side. So we get c sub k plus 1 times k plus 1 divided by, and then this stuff. So k plus 2, k plus 1. So the k plus 1's cancel, so we end up with c sub k plus 2 equals c sub k plus 1 over k plus 2. And this is valid for k equals 0, 1, 2, 3, and so on. All right, here's where it's really easy to mess up, so let's go really slow and be really careful. So we're going to try to find a pattern and solve this differential equation. So we start with k equals 0. And the reason we start with k equals 0 is because it says 0 here. So if it says 2 here, you start with 2. So if you plug in 0 for k, you get 0 plus 2, which is 2. And then here you get 0 plus 1, which is 1. And 0 plus 2 is 2. Okay? If you start with, well, if you go to k equals 1, we get c sub 3, right? 1 plus 2 is 3. 1 plus 1 is 2, so you get c sub 2. And then 1 plus 2 is 3. Now c sub 2, we already have it. It's right here. It's c sub 1 over 2. So this will be c sub 1 over 2 times 3. And I'll leave it like that. You can write it as 6, but usually it's easier to find a pattern when you leave it like that. It looks like we might have some kind of factorial. Let's keep going. So when k is 2, we get c sub 4. And then here we have c sub 2 plus 1, so c sub 3 over 4. And c sub 3 is this. So this will be c sub 1 over 2 times 3 times 4. Yeah, that's 4 factorial. So we do have a pattern. Let me do one more, though. So k equals 3. So c sub 5. So here we have c sub 4. 3 plus 1 is 4 over 5. So c sub 4 is right here. So we end up with c sub 1 over 2 times 3 times 4 times 5. Okay, I think we're ready to go to the answer. So let's try it. So our original y was a power series, right? So y is c sub 0 plus c sub 1 times x plus c sub 2 times x squared plus c sub 3 plus c sub 4, and why not c sub 5, etc. Right, that's our original power series. That's a dot, not a comma. So we have y equals c sub 0 plus, now c sub 1, you can't see it, let me scroll up. C sub 1 was c sub 1, yeah, c sub 1 is c sub 1. Actually, we don't have it. So c sub 1 is c sub 1. And then c sub 2, we do have that. I was looking for c sub 1 and it wasn't there. C sub 2 is c sub 1 over 2. So we get c sub 1 over 2 times x squared, right? That's right there. And then plus c sub 3. Now c sub 3 is right here. So we get c sub 1 over 2 times 3 times x cubed plus c sub 4, that's c sub 1 over 2 times 3 times 4, x to the 4th, and then c sub 5 is c sub 1 over 2 times 3 times 4 times 5, x to the 5th. Okay, there should be 3 dots there. 3 dots. Okay, so y equals, let's clean this up. This is c sub 0 plus, I'm going to factor out a c sub 1 from all of this. So it's c sub 1, I'll use a bracket, so this is x plus x squared over 2. Let's write that as 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5 over 5 factorial. Nice, easy problem. Now, to finish this, notice or recall that e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. Right? So e to the x minus 1 is x plus x squared over 2 factorial, etc. Why did I subtract 1? Well, this almost looks like e to the x. It's just missing the 1. So all of this is just e to the x minus 1. So we end up with y equals c sub 0 plus c sub 1 times e to the x minus 1. Let's keep going. So y equals c sub 0 plus c sub 1 e to the x minus c sub 1. You can write this as follows. Going kind of fast. And we can clean this up. Let's make it look pretty. Let's call this K1, and let's call this K2. So the final answer is y equals K1 plus K2 times e to the x. And that is the final answer. Let's go over it one more time. Long problem for being an easy one. So you start by taking derivatives. Well, you start by writing down y, and then you take derivatives. Don't forget to shift up the index of summation. Okay, then you plug everything back into the original. So we did that, right? Plugged it back in. That's right here. And then you just set these guys equal to k. So you call this k, you call this k. You do it twice. And rewrite everything. And we got lucky because they both started at 0. Now, if they don't start at 0, an adjustment needs to be made. But that wasn't the case in this problem. You work it out. So you set everything equal to 0. Set this equal to 0. Solve for the one with the highest subscript. So k plus 2 is bigger than k plus 1. So you solve for the one with the bigger subscript. Okay, and this is important, right? Don't forget to write this down. This tells us where to start, right? So when you start plugging in values for k, be really, really careful here. This is the part where it's easy to mess up. Well, I suppose there's lots of places you can mess up, but be careful. So plug in 0, 1, 2, 3 until you find a pattern, and then you can write down your differential equation and work it out. So again, this one was much easier. There's harder problems, and there's other ways of doing this. Hopefully I have time and I can make some more videos to show you some other techniques, other ways to do this problem. I hope this helps.